Thanks everyone for turning up today. My name is Maurice Coyle. Put your hand up if you can't hear. It's hard to tell with the headphones. So my name is Maurice Coyle. I'm the Chief Data Scientist with Truata. We're a company that independently anonymizes data for our customers. We become a controller of the data, assume the GDPR risk, and we enable our customers to perform whatever analytics they need to drive their business in a GDPR compliant way. So today I'm going to be talking about some myths and misconceptions around data privacy that we've encountered as we've interacted with regulators and with customers over the last couple of years. So a fairly evocative statement. If consumer trust isn't dead, it's certainly on life support. I think as people have become a lot more savvy and a lot more aware of how large companies are collecting and using their data, and as more and more breaches are announced through the media, people have become a lot more aware and a lot more savvy about how to protect their data, and as a result of that, their trust in a lot of places has reduced in the companies that control their data. So a lot of the concerns that they would have are around things like the types of personal information that's collected, the uses that are made of that information, and then I suppose very importantly how and who companies are sharing their personal data with. So you don't need to look too far to see lots of examples of where companies have inappropriately shared data. And as part of the State of Mind survey performed last year, an independent survey, a lot of customers were expressing concerns around how their data is being used. Most importantly, I suppose, customers really want companies to be transparent about how data is being used, and if anonymity can be guaranteed, many customers are happy for data to be used for analytic purposes. So in today's world, there's two competing forces. On the one hand, companies have an existential imperative to be data-driven. So they have lots of data around their customers, and in order to maintain a competitive advantage, companies have to be able to analyze that data and make decisions off that data. So that's on the one side. On the other, then, we have increasing regulation and increasing customer awareness. The aforementioned customer trust issue is really causing companies to be restricted and constrained in how they deal with data. So these two forces are really competing in a lot of companies' strategies. We've seen the rise of privacy enhancing technologies, or PETs as they're commonly abbreviated. So if you've heard any phrases like differential privacy, homomorphic encryption, synthetic data, or anything like that, these are all privacy enhancing technologies, and a lot of innovation has been going on in this area. There's a lot of really interesting and exciting technologies out there, and as we're also seeing a rise in the tools that allow people to assess the risk that's present in their data. So quantifying the risk of re-identification in a data set is something that until very recently wasn't possible. So now we're starting to see the rise of that. I suppose this talk really centers around the rise of privacy enhancing technologies, and some of the myths and misconceptions that can cause well-meaning companies to do things that might expose them to regulatory scrutiny and obviously fines and sanctions as well. And I'm just going to put this graph up, which is a really important graph when we talk about anonymity and privacy enhancing technologies. The two axes of this graph are privacy and utility. So, and the two are very closely linked. So typically with any privacy enhancing technology, you can either have one or the other. And increasing the privacy of a data set or of an output decreases the analytic utility. So when you're querying and when you're seeing announcements around privacy enhancing technologies, it's really important to be aware of this, because if companies are to, to extract maximum analytic value, typically they have to make some trade-offs around privacy. And on one end of the curve where you have low analytic utility and high privacy, that's the ideal from the consumer's point of view, but obviously not from the company's point of view. The original data would obviously be high utility and low privacy. And one of the kind of misconceptions is that when you use a privacy enhancing technology, you go straight up. So you're increasing the privacy without sacrificing utility, and it's simply not true. In reality, you're moving up the curve. So being aware of these things is really important, and being able to measure them as well is really important. So the first myth that we frequently encounter, in fact it's a collection of myths, is around consent. So if you've been on the web, or if you have an email account coming up to May 25th, 2018, you'll have been seeing banners, and you'll have had a huge number of emails coming to ask for consent or to opt in for various purposes. One of the first myths that we encounter quite often is that companies go straight to consent as their lawful basis for analytics. So consent is used for everything, and it's really, it's in reality, there's a lot of different ways in which you can find a lawful basis for analytics. So consent is just one of 6 lawful bases. There's legitimate interest, execution of a contract, and so on. And really what the important thing to note is that it depends on the relationship with the consumer, first of all, and also the purpose for analytics. Because it's really hard in regulators' eyes to change from consent to another lawful basis if you realize that consent isn't valid. So companies need to do their homework on what lawful basis are we going to use for an analytic purpose, because, as I say, it's hard to switch later. And then the second major misconception we see is that consent is a good fit for analytics. So the banners you've seen on every web page asking for consent, the emails you've received, they're trying to achieve and trying to obtain consent for some purpose, but it's really, really hard to achieve the GDPR requirement for consent. So it's a very high threshold. You have to obtain consent for every purpose and for every provider. Do an opt-in, highly visible, unambiguous consent. So it's a really high threshold to achieve. It's quite difficult to obtain, obviously, and there's a variety of ways in which companies are doing this. And again, the curve that we saw on the previous slide comes into play, because the more compliant a consent dialogue is, the fewer people will provide that consent. So companies are left with this quandary of, should we try to get more people consenting or be more compliant? And it's a really tricky trade-off to achieve. And then also you need, if you're going to target people with personalized offers, you need a separate lawful basis for analytics and also for targeting. So that's a really important point, because quite often people think, I've got consent to target, but they may not have consent to actually analyze the data. So on the left-hand side here, you can see, there's a couple of examples of consent requests that you've probably seen. So we may use your personal data to offer personalized services, to develop new services, or to perform research. And those the wording there is just vague, and it doesn't tell you, first of all, what data is going to be used and specifically for what purpose. So you don't know what new services are going to be delivered, you don't know what research is going to be done on your data, and it may or may not be something that you want to participate in. On the right hand side then, there's a better version of this, which is, we will retain and evaluate information on your recent visits to our website, how you move around different sections of the website for analytic purposes, and to understand how people use the website so we can make it more intuitive. So you know exactly what data they're going to use and what purpose they're going to use it for. So that's kind of an example of how you achieve better compliance around consent. And as you can see, if you had to do this for every single purpose, it becomes quite unwieldy, a lot of effort required from the customer, so it's difficult to achieve. The second myth is kind of related to consent, and it's around data completeness. So, as I said, if you're asking people to do something, by definition, you won't get 100% of people doing it. So, quite often when we talk to customers, we hear things like, our consent models are fine. You know, we're okay operating off a small user base for our analytic purposes, and we've seen things like you know, consent rates less than 10% are pretty common, especially on the web or places where there isn't a very direct connection to the customer. So anywhere mobile or on the web is very difficult to obtain high compliant consent rates. This leads to incomplete data, which, if anyone here is a data scientist or in analytics, you'll realize that, or you'll know that that leads to bias in data. You also have a data retention impact. So under GDPR, you have to justify the length of time for which you retain data, and that can affect your output, as we'll see a little later. And then there's the myth, as I say, is that this has a perceived low impact on performance. When in actual fact, if you're working off two different data sets, one being consented and one unconsented, by definition there's a difference between those two user groups. So you will have a biased data set. Whether or not it affects your analytic output or not, you don't know, and you're not able to find out because you can't analyze the unconsented data. Once you have a small sample or a small subset of users, you will, if you're performing some sort of deep data science on it, you will overfish to noisy signals in that, and you won't be able to mitigate that, and as a result your analytics or your model won't generalize well. So and then obviously if you're building business intelligence reports, the accuracy obviously will be impacted if you don't have full data. And then finally, if you can only retain data for 6 months or 1 year or something like that, then it's really hard for you to make time-based predictions. So you can't compute a customer lifetime value if you don't have a customer's full history. And we can see that on the next slide. You know, we performed this this analysis over some actual data, and we used 1 year of training data on the top and 3 years of training data on the bottom. So on the top you can see the difference between the predicted and the actual values is quite large. So your performance is very highly impacted by only having 1 year of training data. On the bottom, where you have 3 years of data, you have a much closer predictive accuracy. So it really does impact the analytic output, and people need to consider these things when they're looking at consent as a lawful basis, or where any sort of approach where they're using less than 100% of their data. Our third myth is around encryption. So quite often you find people using encryption in place of privacy or anonymity. And I'm not here to bash encryption. Some of the technologies that are out there, homomorphic encryption, polymorphic encryption, they're magic, they're amazing, and there will be table stakes for all companies in the future. You'll have to be using these technologies. They allow you to perform analytics on encrypted data without decrypting it. So it's a really, really strong security protection for your data, but it doesn't equate to privacy, because if you have access to that data, then you have access, and no further action is taken on the data to anonymize it, you have access to the personal data. So it's really important, we think, to make a distinction between security and privacy. So some of the reasons in which, you know, an encryption approach can result in, you know, an unwanted exposure of data. If a decryption key is compromised, you know, brute force attacks are always being developed. Whenever a new technology is created, there will be people who maliciously and also ethically will try and hack it to try and, you know, find flaws so that people are aware of where these exist. And then also, because encryption is typically reversible, you know, you can actually reverse engineer and go back to the original data. And so that's why we're saying, you know, encryption is not equal to anonymity, because the data itself is not anonymized if you get access to it. So the fourth myth is around formal privacy models. If you've heard, you'll probably have seen some announcements from large companies around differential privacy. Okay, again, it's a really, really powerful technique. It's based on mathematical formal models that give you guarantees of privacy, but what's really important to note is that it's not a silver bullet. So if you see a company claiming we have a differentially private analytics system or a differentially private data set, there's a series of questions that need to be answered around that, because the curve that I showed you earlier is particularly pertinent here, because the way you configure differential privacy or k-anonymity or any of those formal models really affects where on that curve you are. So there's a privacy parameter in differential privacy called epsilon. If you choose a low value of that, you have very high privacy. If you choose a high value, you have very low privacy. So when companies, and if you look at the company announcements and then look behind, they usually have white papers or research papers. If you dig into them, typically you find that in order to achieve their business goals, they've chosen a utility first configuration. So they've chosen a high value of their privacy parameter. And so it's really important to note that, like, differential privacy is amazing. To be able to have such control and know something about the privacy guarantees is really important, but it's really important also to, from transparency point of view, that customers are aware that not all differential privacy approaches are the same or equal. And so, yeah, as I say, you know, striking that balance is something where you'll always, unfortunately, find that there's a trade-off to be had, and breaking the link between privacy and utility is very difficult. And under these models, it's actually, you can't do it. You can either have one or the other, but not both. And I suppose, if just in terms of general analytic utility as well, usually you'll produce a data set that is anonymized to a certain degree with a known, you know, privacy guarantee. But if you then need to perform a new analytic function or something like that, then you have to produce another data set, or you know, you can't achieve that with the same data set. So you can end up not preserving general analytic utility, and that's, you know, in a fast moving world where new techniques are being developed all the time, companies need to be able to, you know, to apply new techniques to their data at any point. And then another myth, it's kind of a category of myths again, is synthetic data. So again, and I should note as well, like in Truata, we use a lot of these techniques as part of our platform. You know, they're all very powerful, but the myth around synthetic data is that you can use, the word synthetic seems to flick a switch in people's head that this data is safe to use, you know, that you can use it for any purpose safely. And again, that's simply not the case, because, you know, there's a number of different purposes for which you might use synthetic data. For development or load testing, you might use it for analytic purposes, and you might be sharing the data. And so you can see even now, like for development purposes, analytic accuracy isn't as important as kind of real, you know, being realistic in terms of the load and the character of it, whereas for analytic purposes, you need that to be quite close to the original. And so just to kind of highlight the difference between these use cases and why synthetic data isn't equally usable in all cases, and we'll talk about three different types. So random data is when you assign just random values. It obeys the schema or the fields descriptions of your data, but you just choose random values. You know, and that's kind of minimum risk, because you're not using the original data to generate that. Uncorrelated data is where you generate each column independently of each other, and again, that's really good for development purposes and for some analytic purposes, but typically by breaking the correlations you get low utility, and you get kind of variable risk there, because you can make some decisions. And this is again another reason why being able to measure how much re-identification risk is present is really important, so you know what you're doing at all times. And then at the kind of bottom of the top of the scale in terms of utility is correlated data, but it's also, you know, at the bottom of the scale from a privacy point of view. So, you know, this is kind of similar to the graph we saw earlier. As you're going from random to uncorrelated to correlated data, different synthetic data sets have different levels of re-identification risk in them. So again, it's kind of similar to the formal methods, not a silver bullet, and it's not a one-size-fits-all approach. So you have to be really careful and understanding about what level of risk is still in your synthetic data set. And then finally, the last myth is around in-house anonymization. So, you know, many companies these days are anonymizing their data to some degree for use in analytics, and the variety of technologies, privacy enhancing technologies that people are using, you know, from tokenization or hashing to generalization all the way up to differential privacy. There's a huge toolkit available for people these days. Typically what happens when a company is anonymizing their own data, you will find that they retain the original. So quite often a company will have, you know, a legitimate interest for retaining the original data set. So for a bank, they need to retain their full transaction logs for lots of reasons, fraud or other things. Retail, you need to retain contact details for product recall. So you need to retain your original data quite often. And if you anonymize it, then you typically have two versions of the data. And again, just keep that in mind, that curve that I showed you earlier around privacy and utility. So you're making decisions around that. So the new data set has a certain position on that curve. Typically, it's a utility kind of end of the curve, but again, it definitely has privacy and utility are very related there. They'll usually hash or remove identifying information from the anonymized data set so that you can't identify individual names or email addresses, but there might be a token in place of them so that you can perform some sort of longitudinal analysis. There's usually an internal separation in a company where there's good governance structure in place. There will be an internal separation where the people who have access to the original data don't have access to the anonymized data, and you'll have very strict role and permission controls around access to those two. And that, again, that allows you to have some comfort that the link, it's not as easy to link between those two data sets. But of course, within a company, people move departments and things like that. So it's kind of hard to guarantee that the separation will be maintained. And then most importantly, a single company controls both the original data set and the anonymized data set. So, and that's really important because from a legal point of view, as we'll see on the next slide. So, you don't have to take my opinion for it. You can go and read the Article 29 Working Party opinion on anonymization techniques. If you look at this section where they talk about anonymized data, you'll realize that there's an incredibly high threshold. The reason that threshold is worth trying to achieve is because if you have pseudonymized data, it's considered personal data by the regulators, and under the Working Party opinion, it's still considered personal data and subject to the data protection regulation. If you achieve anonymized data, then it is no longer personal data and it's not subject to the data protection regulation. So this is why companies try to do in-house anonymization, but the real problem with many of the approaches we've seen, and again, as I say, there is the Working Party for Article 29 Working Party opinion on anonymisation techniques, the Irish DPA's opinions, the Dutch DPA's investigations. There's a number of different regulators who are beginning to publish opinions around this. It's very clear if you read the letters of those organisations that if the original and the anonymised data are retained by the same controller, and the anonymised data is also retained at event level or data subject level, so that it's not aggregated to the point where you can't just determine, where an individual event or data subject was, then that data is not considered anonymised. And I say 90% of the times when we encounter this, people are typically retaining the event level data because that is the most useful data that they have. It's the most generally useful way that they can retain that data. So, I mean, this is probably the biggest misconception that we find is around that. And I think we're starting to see the DPAs creating guidances around it, and you'll have a kind of a spectrum where pseudonymization occupies quite a large part, and there's a very narrow slice where anonymization is achieved, and as a result, that's a reflection of the high threshold for achieving anonymization. So I think a lot of these factors kind of they collaborate around companies having some unwarranted issues, because again, these companies are well-meaning. They're doing something, which is better than nothing, but it's important to know, where on that spectrum your anonymization program lies. And so, I suppose as I said at the start, in order to extract value from customer data while, retaining privacy, independent anonymization is the way that we've brought to the market. So, I think that's my time up. Thanks everyone for coming. Hope you enjoyed the talk.